Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel to keep me going, inspired and refreshed. Now if you find my videos important and interesting to your studies, also please don't forget to subscribe. Analyze the frame shown by moment distribution method by determining the moments at all joints. E is constant. So here is the given figure. So the relative stiffness of member AB is 2I over 8, so it's 1/4, 2 times, or 2 over 8, so 1/4, 1 over 6, so 1 over 6 for member BC, and this is 1.5 over length, which is square root of 73. Square root of 3 square plus 8 square, so square root of 73. And let's express that as 1 over 5.696. So before tabulating, the relative stiffness of A is 0. This is also 0. Then this is 1/4 over 1, negative 1/4 over 1/4 plus 1/6. Negative 0.6, so therefore this is negative 0.4. This is negative 1/6 over 1/6 plus 1 over 5.696, so it's negative 0.487. This one is negative 0.513. So for the fixed moments, 0 here, and here it's negative 30 times 6 squared over 12, negative 90. So by symmetry, this is positive 90. And there is no load on CD, so 0, 0. So let's distribute. Negative 90 times negative 0.4 is positive 36 lakh. Negative 90 times negative 0.6 is 54 lakh. 90 times negative 0.487 is negative 43.83 lakh. 90 times negative 0.513 is negative 46.17 lakh. Then because there are no moments here, 0, 0. Carry over, so half of 0 is 0 here. Half of 54, 27. Half of negative 43.83, negative 21.915. Half of 36.18. Then half of 0, 0 here. Half of negative 46.70, negative 23.085. Distribute negative 21.915 times negative 0.4. Then log negative 21.915 times negative 0.6. Then log 18 times negative 0.487, negative 8.766 log 18 times negative 0.513, negative 9.234 log. Then 0, 0 here. Carry over, so 0, half of 13.149, 6.574, half of negative 8.766, negative 4.383, so 4.383 here. Then 0, half of negative 9.234 here, negative 4.617. Negative 4.383 times negative 0.4, 1.753 lakh. Negative 4.383 times negative 0.6, 2.630 lakh. 4.383 times negative 0.487, negative 2.135 lakh. Then 4.83 times negative 0.513, negative 2.248 lakh. Then 0, 0, carry over. So 0 here, half of 2.63, 1.315, half of negative 2.135, negative 1.068, half of 1.575, 3.876. 0 here, then half of negative 2.248, negative 1.124. Negative 1.068 times negative 0.4 lakh. Negative 1.068 times negative 0.6 lakh. 0.876 times negative 0.487, then lakh. 0.876 times negative 0.513, then lakh. Then 0, 0. Half of 0, 0, half of 0.641, 0.32, half of negative 0.427, negative 0.214, half of 0.427, 0.214, 0 here, half of negative 0.449. negative 0.224. So half of distribute negative 0.214 times negative 0.4, 0.086 lakh, negative 0.214 times negative 0.6. So let's lock it finally. So 0.128 lakh, then lakh finally. That's a small moment compared to the initial moments of 90. 0.214 times negative 0.487, negative 0.104 lakh, final lakh. Then 0.214 times negative 0.513, negative 0.110 lakh, final lakh. Then half of 0.2128, 0.064 lakh, then lakh finally. Half of negative 0.110, negative 0.01055 lakh, lakh finally. So adding the moments here, 35.273, this moments MBA, 70.548, this is first phase moment. Adding the moments here, so it is expected negative 70.548 equal. Then you just check, you add that. Adding the moments here, 58.211, so here, negative 58.211. And lastly here, negative 29.105. So for the side sway moment, let's have the deflected shape. So this is the deflected shape. We have delta for AB, delta BC for BC, and delta CD for CD. This is theta, opposite is 8, adjacent is 3, hypotenuse square root of 73. So let's have this triangle. This is delta here. Then theta is opposite to this triangle, opposite to the vertical and perpendicular to CD. So this is theta. Opposite of theta is 8. So this is 8. This is delta BC and this is delta CD. So opposite of theta is 8. Adjacent to theta is 3. Hypotenuse is square root of 73. So from the figure, delta as to 8 equals delta BC as to 3 equals delta CD as to square root of 73. So delta BC is 3/8 of delta, while delta CD is square root of 73 over 8 of delta. So having related the displacements or side sway of the other segments, we can now compute the side sway moments. So moment AB side sway is negative 6 EI, so EI is taken 2, then delta over length 8 square, so negative 3 delta over 16. For BC, the rotation is counterclockwise, so it is treated negative. So it is negative 6, EI is 1, then delta is negative 3/8 of delta over length, length square 6 square. So it is positive delta over 16, while for CD is negative 6, EI 1.5, delta CD is square root of 73 over 8 delta, positive, because the rotation is clockwise, over length square, so negative delta over 7.59467. So therefore, the LCD of the denominators is 60, LCD is 16 times 7.59467. So therefore, the moment for AB, the assigned moment is negative 3 delta. Let's take delta 1 over 16. So multiplying this with the LCD, which is 16 times 7.595. Let's just round this off to 4 significant figures to 7.595. So negative 3 times 7.595 is negative 22.784 kilonewton meter. The side sway moment for BC is delta over 16 times 16 times 7.59467. So it is 7.595 round of kilonewton meter positive. Then for CD, delta times negative delta over 7.59467 times 16 times 7.59467. So it's negative 16 kilonewton meter. Then for the equation, we find additional equation. We find a point of intersection between AB and CD as shown in the figure. And let's solve first for y and z. So y as to 8 equals z as to square root of 73, the hypotenuse, equals 6 meters. This is 6 meters as to adjacent to theta is 3. So we apply similar triangles. Y, because this is also theta, the angle here is theta. So y as to opposite of theta is 8 equals z as to hypotenuse. Hypotenuse is square root of 73 equals 6 meters. This is 6 meters as to adjacent of theta, which is 3 meters. So y is equal to 16 meters and z is 2 square root of 73. So therefore, the distance from D to O is 2 square root of 73 plus square root of 73. That's 3 square root of 73. The distance of A to O is 16 plus 8, so 24, or 3 times 8. So setting up equations. So VA, let's assume moment AB as clockwise. At D also. So we have V sub D clockwise moment for DC. So V sub A times 8 plus 16 plus V sub D times 3 square root of 73, this distance here. Then plus 50 times Y, 50 times 16, minus 30 times 6 times 3, the moment of this uniform load. Then equals clockwise moments MAB plus MDC. So that's the equation, and let's have it on the next slide. So this was the equation we left from the preceding slides. So simplifying and replacing VA as 1/8 of MAB plus MBA times 24 plus 1 over square root of 73 of MDC plus MCD times 3 square root of 73, then equals negative 260 plus MAB plus MDC. So take note that this equation for VA is derived by experience if we sum up moment about B, taking AB as a free body. Then we have MBA here, which is assumed to be clockwise. Same is true with CD. Then we sum up moments about D. So V sub D times square root of 73 equals MDC plus MCD. So that's why we have 1 over square root of 73 MDC plus MCD for shear at D. Then simplifying further, 2 MAB plus 3 MBA plus 2 MDC plus 3 MCD equals negative 260. Then let's have the moment AB, but before that, let's have the moment distribution for side sway moments. So remember that for AB, it was negative 22.784, negative 22.784. For BC, it was positive 7.595, 7.595. And for CD, negative 16. So we begin here 0, 0. So I will not put 0 because the distribution factor is 0 to save space and time. So let's proceed to joint B. Negative 20 quantity, negative 22.784 plus 7.595 times negative 0.6, so 9.113 lakh. Then replace negative 0.6 by negative 0.4, 6.076 lakh. Then here, quantity 7.595 minus 16 times negative 0.487, 4.093 lakh. Replace negative 0.487 by negative 0.513, 4.312 lakh. Then 0, 0. Carry over, so half of 0, of course 0 there, half of 9.113, 4.556. Half of 4.093, 2.046. Half of 6.076, 3.038. Then half of 0 is 0 there, half of 4.312, 2.156. 2.046 times negative 0.4, negative 0.818 lakh. 2.046 times negative 0.6, negative 1.228 lakh. 3.038 times negative 0.487, negative 1.48 lakh. 3.038 times negative 0.513, negative 1.558 lakh. Then 0, 0. Half of 0, 0. Half of negative 1.228, negative 0.614. Half of negative 1.48, negative 0.74. Half of negative 0.818, negative 0.409. Then half of 0, 0 here. Half of negative 1.558, negative 0.779. Negative 0.74 times negative 0.4, 0.296 lakh. Negative 0.74 times negative 1.228, 0.444 lakh. Negative 0.409 times negative 0.487, 0.199 lakh. Negative 0.409 times negative 0.513, negative 0.210 lakh. Then 0, 0 here. Carry over, so 0 here, half of 0.444, 0.222, half of 0.199, 0.01, half of 0.296, 0.148, 0 here, half of 0.21, 0.105. 0.1 times negative 0.4, negative 0.040 lakh, final lakh. 0.1 times negative 0.6, negative 0.06 lakh, final lakh. 0.148 times negative 0.487, negative 0.072 lakh, final lakh. Negative 0.487, negative 0.148 times negative 0.513, negative 0.076 lakh, final lakh. And 0, 0, half of negative 0.06, negative 0.03 lakh, final lakh. Half of negative 0.076 here, negative 0.038 lakh, final lakh. Adding the moments in this joint, 18.650 here, negative 14.515. So this is positive 14.515. Check that by adding the moments here. Adding the moments here, 13.112. So adding the moments here, negative 13.112. Finally, in this joint, negative 14.556. Therefore, moment AB is first phase plus second phase times R. So moment AB is first phase 35.273 minus 18.65 R. Moment BA is 70.548 minus 14.515 R. Moment BC, moment DC, this one, negative 29.108, then minus 14.556 R. Moment CD, negative 58.211, then minus 13.112 R. So substitute in this equation here, 2 times 35.273 minus 18.65 R plus 3 times quantity 70.548 minus 14.515 R plus 2 times quantity negative 29.105 minus 14.556 R plus 3 times quantity negative 58.211 minus 13.112 R equals negative 260. Combining like terms, then simplifying, 49.341 minus 149.293 R equals negative 260. Finally, we can solve R. R is 2.072. Then from there, we can compute the moments. Moment AB is equal to 35.273 minus 18.65 times 2.072. So moment AB is equal to negative 3.370 kilonewton meter. Moment BA, 70.548 minus 14.515 of 2.072. Moment BA is 40.473 kilonewton meter. Moment BC therefore is negative 40.473 kilonewton. This is the moment at B. Moment CD is negative 58.211 minus 13.112 of 2.072. So moment CD is equal to negative 85.379 kilonewton meter. Then moment CB is positive 85.379 kilonewton meter. Finally, moment DC is negative 29.105 minus 14.556 of 2.072. So moment DC is equal to negative 59.265 kilonewton meter. So you may compare the results for joint moments with the solution by slope deflection equation, and the answers are very close. So that's it for this problem.